Gravitational potential energy, elastic potential energy. What is the difference between the two types of potential energy? Hello, Cypals! I am Ma'am Christine Ragos, your science teacher for today. In this episode of Agham Alam Hub, we are going to differentiate the two types of potential energy. We will also compute the gravitational and elastic potential energy of a system. Finally, we are going to appreciate the important applications of gravitational and elastic energy in real-life situations. In the next few minutes, we will explore science for another moment. Remember that mechanical energy is the energy of an object due to the position of the object or the movement of an object. Mechanical energy has two forms, the kinetic energy and the potential energy. Kinetic energy is the energy an object has due to its motion. It is defined as the work required to accelerate a body of a given mass from rest to a certain velocity. Meanwhile, potential energy is the energy stored in an object. It is a form of energy that is due to the position of an object to the other objects or a reference point. Potential energy is further classified into two. What is the difference between elastic potential energy and gravitational potential energy? Gravitational potential energy is the energy associated with an object due to the object's position relative to the gravitational source. Gravitational potential energy depends on the height from a zero level. For example, the heavy ball of a demolition machine is storing energy when it is held at an elevated position. This stored energy of position is referred to as gravitational potential energy. If energy is stored by lifting an object to a certain height, then it can be determined using the following equation. For example, let us determine the potential energy of a 1.5 kilogram book that is placed on a shelf that is 2.5 meters high. Let's use the formula for gravitational potential energy, which is gravitational potential energy equals mass multiplied by acceleration due to gravity and the height of elevation. Take note that the value of acceleration due to gravity is a constant, which is 9.8 meters per second squared. After substituting the given values, we will have gravitational potential energy equals 1.5 kilogram times 9.8 meters per second squared times 2.5 meters, which is equal to 36.75 Newton meter or joules. Gravitational potential energy is only one of the very few forms of energy that can be used for electrical energy generation at a very large scale. An example of this is an elevated dam or reservoir like the Ambuklao Hydroelectric Power Plant in Bocod, Benguet. The Ambuklao Hydroelectric Power Plant is one of the oldest power plants in the country and was among the first large hydroelectric power plants constructed in the Philippines. The development of the Agno River for purposes of hydroelectric power generation, flood control, and irrigation had been conceived as early as the late 1940s. When the water from the elevated reservoir is released, its stored potential energy can be transformed to mechanical energy, which can be transformed into very essential electrical energy. Elastic potential energy, on the other hand, is potential energy stored in a compressed or stretched spring or object. For example, When a slinky is in its unstretched position, there is no elastic potential energy. When you stretch the slinky, you do work on it. The slinky therefore acquires energy and is momentarily stored as elastic potential energy. As long as you keep it stretched, the elastic potential energy remains stored. If x is the distance that spring is stretched from its resting position and k is the spring constant measuring the stiffness of the spring in newtons per meter, then elastic potential energy is determined using the following equation. For example, an object with a spring constant of 5.20 newtons per meter has a relaxed length of 2.45 meters. When a mass is attached to the end of the spring and allowed to rest, the vertical length of the spring becomes 3.57 meters. Let us calculate the elastic potential energy stored in the spring. Let's use the formula for elastic potential energy, which is elastic potential energy equals 1/2 multiplied by spring constant and the distance compressed or stretched. To determine the distance stretched, we will subtract the length of the spring when it is stretched to the length of the spring when it is unstretched. In this example, we will subtract 2.45 meters from 3.57 meters, which is equal to 1.12 meters. Now, let us substitute the given values to the formula for elastic potential energy. Elastic potential energy equals 1/2 times 5.2 newtons per meter times 1.12 meters squared, which is equal to 3.3 newton meter or joules. Important application of elastic potential energy involves mechanical devices and vehicles. Because springs can remain in a compressed and stretched state for extended periods, elastic potential energy is fundamental for mechanical devices such as shock absorbers in cars. This potential energy can be used to reduce the impact of disturbance in motor vehicles. Springs, which exhibit elastic potential energy, also have variety of uses such as in computer keyboards, mattresses, door handles, and many more. In this episode of Agham Alam Hub, we differentiated the two forms of potential energy. Gravitational potential energy is energy stored in an object due to the object's position relative to the gravitational source. Gravitational potential energy can be determined by the product of mass, acceleration due to gravity, and height. While elastic potential energy is energy stored in a compressed or stretched spring or object, it depends on the distance of the string that is compressed or stretched. Elastic potential energy is determined by the product of 1/2 of the spring constant and the square of the distance that is stretched or compressed. Important application of gravitational potential energy involves the use of the stored potential energy that can be transformed to more usable form of energy such as mechanical and electrical energy, which is observed in hydroelectric dams and elevated reservoir like the Ambuklao Hydroelectric Power Plant in Bocod, Benguet. Important application of elastic potential energy involves the use of springs in cars and other mechanical devices as shock absorbers, as well as other everyday objects that we use such as computer keyboards, mattresses, door handles, and many more. That's all for today, Disciples. Don't forget to like, share, subscribe, and turn on the notification bell. See you again next week for another moment. Only here in Agham Alam Hub, Paladyans, SciTech Portal. Bye!